Okay, I think we should continue the guy that was shooting this one.
Anime?
Yeah, the animation, but with more code. We will make him fire some balls, and maybe make some enemies appear, and so we can shoot it. So we add a guy, a stickman. In it, there was two layers, one for the stickman, one for the gun. In the gun, we set it so the little crust, 00, was on the shoulder of the stickman.
Mm-hmm.
So when we make, when we will make the gun rotate, it will rotate correctly. And then in the gun, there was the animation on the second frame till the end. And we simply added some code. The code was, this is big. Longer one. Yeah, so the code was simply stickman.gun. So the gun inside the stickman stop, so the animation doesn't start at the beginning. And then when we click on the stage, it called the function shoot, which simply make the gun play at the frame 2. So I think we should make the guy first of all rotate his arm and then shoot a ball in the direction of his arm. And maybe we should make the ball then bounce on the walls. So is it okay with you?
Yeah, but I'm just trying to make this smaller. I can't
Uh,
really get there.
how
Uh,
can you do that?
does it work here? Not, I don't think so. Well, doesn't matter.
Okay. Oh yeah, maybe try to click on the little double arrow on the right. Yeah,
Okay.
is it better?
Yep.
Okay, perfect. Okay, so first of all, we will make the gun rotate uh, and follow our mouse. So just let me a second. I will take my tablet to explain you some math things that we'll need. Okay. Okay. So when we will move our mouse, the gun will rotate. So maybe put the guy in the center and just rescale it a little bit so it is like smaller.
Mm-hmm.
Maybe like, yeah, right there. If you hold the shift key, it will, yeah. Uh, Perfect. So in our code, what we want to do is at each frame, we want to check if the we want to calculate the angle between our mouse and the rotation point of the gun, which is the shoulder.
So it's the run function.
Yeah. So we will add an add event listener that will execute at each frame. So it's a stage.add event listener event that event that enter frame, and we'll call the run function. E colon event.
Whoops.
So I will ask you the question. It's a math problem. In fact, if you make a lot of video games, you will see that for collisions and all this stuff, it's a lot of math. And it's perfect because it's the kind of math that you are currently learning in school. So I will just ask you the problem. If we have the shoulder here, this is the shoulder of the guy, and we have the mouse right here.
Uh-huh.
How do we the goal is to rotate the gun so it will be like that. But to do that, we have to know the angle right there.
Oh, how do you do that already? Um,
First of all, think about what do we know about this point here, the shoulder, and the mouse.
oh, we know the position.
We know the position, in fact, the coordinates of those points.
Yeah,
So
X, Y.
yeah, we will call it this way. This way. So this one will be maybe SX and SY for shoulder X, shoulder Y, and this
Mm-hmm.
one MX, MY. So how
So,
could we find the angle?
um, if that's there. Uh, I remember doing this in secondary two. Kind of
It's
forgot.
supposed to be in four. I will help you a little bit by
I
drawing a rectangle, triangle. Or
Yeah. In I remember doing something like this either this year or last year, like trying to find an angle with I'm not sure coordinates.
does sin costan tell you something?
Yeah, I saw that on my calculator.
Yeah, but have you done this year?
Nope.
No. Oh, I'm really surprised. You haven't do sin, cos, or tan this year.
No.
Oh, okay.
I did more than a half the year was like functions and relation.
Okay, but you were in secondary four.
No, I'm free.
Oh, three. Oh, okay, okay. I thought you were in secondary four. Oh, okay. Then I will explain you. I will explain you just a little concept. But anyway, you will see it next year. Okay. So in all rectangle triangles, uh,
Yeah. Um, is it like Py Pythagore or
it,
something?
yeah, it's like Pythagore, but it's rapport
It's
trigonométrique.
it's more similar.
It's more similar, but it's about angles and length of sides of rectangle triangles. So it's really simple to remember it. It's so ka toa, but they will teach you that next year. I won't go in all details. So ka toa. Why so? Because it says sin of an angle. So this is a function. It's the function sin. Sin of an angle. So I will just write like this symbol to represent the angle. It's equal to O on H. So the opposite side of the angle on H, the hypotenuse. The
Hmm.
hypotenuse. So
Hypotenuse is the one longest one, right?
yeah, it's the longest one. So for example, if this is my angle,
Mm-hmm.
I can say that this side, the opposite side to the angle,
Mm-hmm.
divided by the hypotenuse is equal to sine of this angle. I, I will just show you an example. If I have, I don't know, 30 degrees right there, and this side is 10, and I want to know this side, I just have to write this
The
equation,
uh-huh.
like sine of 30 equals I don't know what on 10.
And then you I don't know how to
Isole.
say it in English. Isole the O.
Yeah, exactly. So that you type this on your calculator, and it's going to work 0.5 multiplied by 10, and you will find that this side is as a length of 5.
Okay.
And uh, there are three of them. So k toi, k means cos of the angle. It's equal to the adjacent by
So
adjacent.
basically, they're like almost all the same,
Yeah, they are all the same.
but the beginning of each is sin, cos, tan.
Yeah, but it's changed. This one is the opposite on the hypotenuse, adjacent on the hypotenuse, and tan is opposite on the adjacent.
I need to write this down.
Yeah, maybe just tan it will be the one that we are going to use. It's more useful. Yeah, I will let you, or maybe
So
just take a screenshot, or
yeah, that's gonna save me a bunch of time. Uh,
uh,
PRT.
I will just write the last one. Tan equals adjacent on
As
no. In fact, it is kind of easy. You will see next year. I don't know. Some people find that really hard, but there's nothing more than what I just said.
I find it simple.
Okay, perfect. So that's it. So how are we going to use that? Um, let's say we have a triangle like that. Um, this one right there. And we know that this side has a length of 5 and this side has a length of 9, and we want to know this angle. So we have to say that for this angle, this is the opposite side and this is the adjacent side. So we can use TOA. So this is the way that we remember it. TOA, opposite, adjacent. So we can write tan of the angle that we are looking for equals the opposite side. So
So basically, we're all the time we're on isole quelque chose.
yeah, exactly. Always. We always know two of the three. But to remove tan, we have to do the opposite of tan, which is tan minus 1 or arctan. So like if I want to remove the tan right there, I do tan minus 1 on each side. So on the left side, it removes the tan, and on the right side, it becomes tan minus 1 of 5 on 9.
Why do you have to do the opposite again?
Because in math, we always do the opposite when we want to remove something. Like if I have x plus 2 equals 5 and I want to remove the 2, I do the opposite on each side. I do minus 2 on each side. So that's why it becomes x equals 3, because we did the opposite.
Okay.
Here's it's the same thing. We did the opposite of tan, which is tan minus 1. It's simply the opposite function of tan. Anyway, uh, how much it gives you if you make the operation. So I think you have to type 5 divided by 9.
Wait, I need like to change it. Where is it? Uh, is it standard or yeah, it's scientific. Where is tan?
Tan is
Here.
yeah. So 5 divided by 9,
5 divided by 9.
and then you have to press invert. There is like a checkbox on the top left.
Mm-hmm.
I and V, yeah, invert. So this is the invert function of tan, and